Welcome to the second talk, which is migrating to Java 11 in real application, because there are some how-tos or tutorials how to migrate or to 11, or why 9, 10, 11, 12 and the preview of 13 are so cool and so great, but usually they don't need to work with Struts application, right? If you know what I mean. So again, this is me. We're not going to go through that again. What might be important for this talk is that I'm working on Java since Java 1.3, so it's like 15 years. I even backported some code to Java 1.2, and 80% of time when I'm developing something, I'm doing it on JVM, basically, which is Java plus Scala. So Java even haunts me when I'm on holiday. As you can see, there was a hotel called Java in Spain, so you're never free to leave it. We already covered in the previous talk, who are you? You are mostly Java and Kotlin backend developers, which is cool because we share the same level of an area of interest. That's why I think and I hope you'll benefit from this talk. So agenda for today, it's about crucial non-technical changes like politics, licenses, release cycle. It's going to be about removed and deprecated stuff, and how to run your application on Java or JVM 11. Excuse me. What's not covered today is all the new fancy stuff. Basically, we don't have that much time. Let's just do one more voting. Who's running Java 8 in production? Cool. Who's running 7 or earlier? Okay. I have something for it, just, you know. But please don't tell me you've migrated 2 weeks ago, okay? Who's running Java post 8? Oh, quite a few folks. It's getting better and better. That's great. So, to begin with, Oracle JDK versus Open JDK. Do you know the difference? Can you tell the difference? So there are two JDK/JVMs. Both are maintained and released by Oracle Corporation. This one is open source. It's a GPL v2 plus class path exception, and this one is a proprietary one. It has a custom license, more or less. And when it comes to technical comparison, they are more or less equal. I mean, if you diverge to the edge of the flat earth we all live on, you might find the creatures, as Grzegorz told you last time, that are nasty. And some people say that there are some technical differences between them, you know, some certification issues and so on and so on. But generally speaking, if you compile your system on one JDK, it will run on the other and vice versa. I mean, technically there is almost no noticeable difference. However, there's a difference when it comes to other issues like license, money and release cycle. Both are maintained by Oracle, and to make the release cycle easier, Oracle decided to shift some things from this proprietary JDK or JVM to the open one, like they did that for JFR, for example, to make the releasing new versions of Open JDK easier. So there's a new release schema. Basically, some say they got inspired by Canonical and Ubuntu, so that new JVM or new Java is going to be released every 6 months, in March and in September, and it's not going to be postponed by features. I don't know if you remember that, but I remember that we were waiting for Java 6, then 7, then 8, and for previous versions as well, and it always got late. It was because they needed some feature to be shipped in this version, and the feature wasn't quite ready because serialization, and that's why it got postponed by months, years sometimes. It is not going to happen anymore. It doesn't happen anymore. It's like if you meet the timeline with your feature, this feature will be shipped or released. If you don't, sorry, you missed the release, you need to wait for the next one. That's how it works. Oracle, for the Oracle JDK releases, they call it long-term Ubuntu. So they release JDK as long-term support every 3 years. So it was Java 11, then it will be Java 17 and Java 23 and so on. That's why Java 11 became kind of popular, and that's why many people didn't really bother with Java 9 or 10, because they were, we're waiting for 11 anyway. And there is also instant lack of support from Oracle when it comes to Open JDK, meaning they don't even support this dash version colon release, because previously you could tell your JVM to behave like an older JVM. So you had, let's say, 7 installed, and you can tell it behave like just as if you were 5. Now it's not possible for Open JDK. I mean, that's why there's instant lack of support from Oracle when it comes to Open JDK, and we can see that on this nice chart from Azure. I will zoom this boxes in the bottom to begin with. So there are these publicly available binaries, and they are unsupported, meaning you can't call Oracle and yell at someone, basically. There's this Oracle commercial support you have to pay, but I'm not sure if you can yell. And then there is this Oracle extended commercial support. So roughly speaking, gray boxes or gray steps mean Open JDK, and the pink ones mean Oracle JDK. So as you can see, we are in mid of 2019. We are more or less here. So 13 is going to be released. 11 is Open JDK from Oracle's point of view is not supported anymore, and you could pay for LTS to get long-time support from Oracle. This leads us to this triangle. Like in a software industry, you can have something quickly, cheap, or it can be a good software, right? Pick two. You can have stable, secure, or free Java/JDK, and you have to pick two when it comes to Oracle, of course. So assuming you'd like to have something secure, meaning you get the updates, like security bug fixes and so on, you either have to follow this gray path to be free, but then you're not stable, meaning every 6 months you need to upgrade. A little problematic maybe. If you don't want to follow these steps but have a stable JVM, then you need to pay. So it's not free, it's stable then. Okay, but there are other vendors and JVMs. You can have your JVM from Red Hat, IBM, there's Azure, of course, there's Google, Amazon, and maybe even more companies. So they release their JVMs for free, or you can pay them with different level of support and so on. So, because people think, and this was the way of thinking even before for previous versions, because if someone wanted to install Java or run Java program, this meant in the back of their mind they need to go to java.sun.com. Now they go to javaoracle.com to download Java. That's the way people think, that Oracle means Java and Java means Oracle. No, it's not. There are other vendors, there are other JVMs. So when it comes to migrating stuff to Java 11, you say, I want to migrate to Java 11 plus. I'd like to get to like Java 11 or Java 12, okay? And then that's them saying, no, because Java 11 is paid, you know? And you get such discussions in your companies, in your canteens, in the forums. And it's from my point of view, it's really problematic, but because it's like discussing with all these idiots who will tell you that that the earth is flat and you should be wearing tinfoil hat for extra protection from cosmic radiation. This is them, basically, okay? They are so stupid, more or less, because they tell you that the earth is flat, vaccines kill you, you should be wearing tinfoil hats, and Java 11 is paid. This is the, I mean, if they tell you Java 11 is paid, imagine this tinfoil hat, okay, on their head. This is the level of the discussion we're going to have. Sorry. So you can repeat after me, because they say Java 11 is paid, you can repeat after me, Java 11 is not paid. Come on. Java 11 is not paid. Again, Java 11 is not paid. Jeszcze raz, голоснее. Java 11 is not paid. Remember that, folks. Java 11 is not paid, okay? And stop wearing tinfoil hats. Java is still free. There's a link here. You can read that. They explain why Java is free. Basically, Java is not Oracle JDK, to put things short. Okay, you need to pay for Oracle JDK. Who read the license of Java from Oracle 7 or something from Sun? Who read the license?
Just accept it.
Exactly, I didn't read it either. But there are some folks who say they did that they read the whole license. And the license more or less says that Java was paid even before 8. It's just it was free for desktops and servers, but if you had like in this shopping malls you have these kiosks or ticket machines, and they're running Java, then you had to pay Sun/Oracle for running Java there, basically. Now they extended it to other areas to finally get some cash from banks, cloud vendors, or I don't know who else. So you need to pay per CPU to get the support and so on and so on, but it's not obligatory. I mean, you don't have to run Oracle JDK. There's a thing or a movement or a consortium or foundation, I don't know exactly what the legal form of it is. It's called Adopt Open JDK. So after 6 months where Oracle kind of abandons Open JDK, there's one of the companies from this consortium, I believe 11 is maintained by Red Hat, but I might be wrong. So they still keep maintaining Open JDK, the given version. So as you can see, you could select Open JDK 8, 9, 10 at the time I made the description, 11 and 12. You could choose the hotspot Open JDK, and you could select the platform. You could choose Docker, various operating systems, or Windows if you preferred. So there's an alternative which is free, which is not paid, so you don't have to pay to run Java 11. Do you recognize this slogan? Yeah, I see some Java veterans. Do you recognize this one? Because this was the promise and this was the reality, right? We've been there. We've debugged our AWT applications because they run perfectly fine on Windows and didn't want to run on Solaris. Anyway, when it comes to migrating from Java 8 to later versions, say Java 9 and so on, Oracle made kind of a claim, promise, or statement, whatever we choose, which can be distilled as this: that normal Java Standard Edition applications should just work. There are two caveats with that. First, what's normal? It's maybe you're normal, maybe you're not normal. I mean, you're not psychologist or IT psychologist to tell that. Okay? Then another one is should. They didn't promise it will work. They said it should work. Okay, so maybe it won't. Eh? And I promised you two caveats. So there's a third one because this is off by one errors. It's Java Standard Edition. Okay, so if you have something from Java EE/Jakarta EE, or just Jakarta, it might not work. Again, because it's out of the range. It's not even normal and should. Okay, so if you have JPAs, Springs, and so on, it's not Java SE. And unfortunately, because I'm after two successful, at least I hope so, and so the reality seems to confirm migrations to Java 11. In all other cases, it might not be just a single step, because previously we were used to okay, so you take a new JVM, you install it, you take new jars and you run it. In few corner cases it doesn't work, usually it works. Well, it didn't work for me when I was migrating from Java 6 to Java 7 because of the ECB. I have shown you in the previous talk, but usually it worked like that, right? It's not the case anymore. But before we start migrating, we need to get the time and the money. So we need to convince the business, right? So before we even start reading about new ways of migrating to Java 11, you need to convince someone to pay for that, to find, I don't know, a few weeks, maybe to get a budget and people and so on, because I assume you want to be the people. So reason number one, and I think I use them. In my case, they work. It's Java Flight Recorder and Java Mission Control. Java Flight Recorder is more or less like a black box in a plane, which actually is orange, but it doesn't matter. So it records how the plane performed since takeoff, or even before takeoff, after landing. Okay, so this is what Java Flight Recorder does. With little overhead of 1 or 2%, if properly configured, it will record all the parameters like memory consumption, threads, exceptions, garbage collection, and so on and so on. So you can, after the flight, you can analyze that in Java Mission Control, basically. So they work like Siamese twins. String has array of bytes inside. So if you happen to run an application which works with a hell lot of strings, and these strings quite accidentally happen to be in, I call it the ASCII range, the Western range, then you, up to Java 8, you were wasting half of the bytes, because Java was keeping strings inside as UTF-16, and every second byte was 0. Now, in string there's an integer flag, and the character array was turned into byte array. Meaning, if your name is just like mine, Piotr, you will use 5 bytes. And if your name is it's written in like in Ukrainian, or it's Paweł in Polish with L in dash, then you'll use 10 bytes. In our case, we were transferring XML files into another data. So during 1 minute, one of our applications was mangling 24 gigabytes of RAM, and it happened that 8 gigabytes and a half was strings, and after migrating to Java 11, instead of 8.5 gigabytes of RAM, we have more than 4, but not 5. Meaning, out of 24 gigabytes, we saved 4 gigabytes, which is 1/6, like 17%. It might be a nice impact on the performance and the occupation of the memory, the RAM, and the money you pay on the cloud. Basically, that's money. That's the way to convince the business. This application class data sharing. So when your application starts and it needs to read the whole class path and find out in which jar there's this class and then there's this method, and build like there was this movie with Tom Cruise, so they was setting how the future would look like. But it's so more or less when JVM starts. What was the name of the movie? Nobody remembers, including me. Anyway, The Minority Report, yeah. So when JVM starts, it needs to read all the bloody jars and the classes inside and put them in memory and remember what comes where from and so on. So to keep this big image. So and when you have the same class path for another instance of your application, it's doing it again and again and again. So instead of doing it again and again, you can just record it, you can dump it, and then Java or JVM during starting can take a look. Okay, I have the same class path, so instead of reading that again, I'll just use this dump, which is called application class data sharing, or generally speaking, class data sharing. Better integration with containers. Since Java 10, Java can read the constraints put on Docker in a better way. So if you use Docker /Kubernetes / whatever, I think you should migrate to Java 11 because you will profit from that. Other big changes, in my opinion. Java Unified Logging. So previously, if you wanted to know what Java is doing under the hood for each subsystem, you had a different set of logging parameters. Now everything got unified, so there's an easy and consistent way of telling JVM to perform logging of internal stuff. Of course, there are modules / Jigsaw which have impact on our systems as well. There's JShell, so finally Java has REPL, because for years I was using Scala mainly for Scala's REPL. So instead of running or creating another dummy hello world with this public static final void method, or running a dummy JUnit test, you can just spin off a JShell and type and see how the code behaves. More or less, it's like the console for Java, shortly speaking. Of course, we have var, which is a new type indicator. So for local variables which are instantly declared, and defined, the compiler will infer the type. Basically, it's a new var is not, if you're going to change your job and you're expecting to have like this recruitment talk, var is not a new type. It's a type indicator, more or less, because you can still have var equals 10, and you can have var break equals 10, because break is a registered keyword like void or whatever, and var is not a keyword. It's just a kind of an indication or to the compiler, hey, you should infer the type. This is nice. Finally, we can write scripts in Java, so JavaScripts. We can have proper JavaScripts. And what I like even more is that finally whoever they happen to be, are removing stuff from JVM. And from Java, generally speaking, because for years, you know, there were these upgrades in various technologies like Python, PHP, Perl, .NET. I mean, everyone was breaking the backward compatibility for some other cool new features, and Java wasn't doing that. And now finally they do that. They remove classes, methods. They make your old code not work, or in some cases it might not work with a new JVM. But they do that for the benefit. So I think they got, you know, this chain and balls, right? So it was slowing development of Java and moving forward of the whole ecosystem. Now it got faster. So I think this was a good move, but of course a lot of people complain. So let's talk about this removed stuff. First, do you recognize this name of the package? Sorry, module. It's a module. It says Java Standard Edition, Enterprise Edition. So Enterprise Edition was inside the Standard Edition. Quite weird, I'd say. So they decouple it. I mean, if you have classes from this Javax package or something that may become a Jakarta, it's not in JVM itself anymore. It got decoupled to separate jars. Who has Corba or used Corba in Java? Corba is no more. Sorry. JavaFX also got decoupled. Applets got removed. There are no more applets. So if you are writing applets like I did in the good old times, there are no more applets. Sorry. Java WebStart is removed. Many XX parameters got removed. In Java 8 there were almost 800 XX parameters. In Java 11 there are 500 something. So along the way they chopped off a lot of them, but they introduced a 20 something. So it might happen that some ancient, long time not used parameters are gone. Maybe there are some that you used are also gone, but then you'll get that from the change logs. Who's using sun, misc, and save?
Atomic integer.
But I mean, among you, who's using sun, misc, and save in your code base? Nobody? Okay, who's using Spring? Who's using Spring? Come on, keep your hands up. Who's using Hibernate? Keep your hands up. We can get through the list like this, and I believe a lot of people, if not everyone, would keep their hands up. Basically, if you use Spring, or Spring uses you, sorry, you are using sun, misc, and save. Only you don't know that. So it might be that if you have your application with some Asian dependencies, it might not work with new JVM because some methods are gone. For years, Sun was, and then Oracle was saying, don't use bloody sun, misc, and save. Everybody said, yeah. And now finally, unfortunately or not, your fingers might get stuck under the keyboard. Of course, there's much more. There's also a list for Java 12, so that you can. These are long documents. You can analyze them. What got removed and what you should use instead. Sometimes. Let's talk about deprecated stuff. So deprecated stuff. Do you know what's enhanced deprecation? Do you recognize this add deprecated annotation? Okay, what does it mean? Nobody knows exactly.
It means that it will be removed at some point.
Yeah, it means it's deprecated, and it can have actually two meanings. It's like you should better not use it because it wasn't a good idea. We just keep it for backward compatibility, and we'll never remove this code. And sometimes it was one day we will remove that. and we didn't know which is which. That's why they introduced enhanced deprecation and has new annotation with uppercase D and has this parameter for removal true, which says if the for removal is set to true, in the next major version there will be no more this code. It will get removed. So if you find a warning from your compiler saying that you're using deprecated for removal code, you should better stop using it, basically. In case you don't happen to compile the code, but the code is still using it, like external dependencies you get from Maven, because why not? You can use JDepScan, so it will tell you that this that basically these jars are using or calling this deprecated API, which will get removed. So we can use it to scan your dependencies. Concurrent mark sweep got deprecated. Nashorn got deprecated. Who's using Nashorn? JavaScript engine? Nobody? Great. And in my opinion, just my personal opinion, dip reflection got also deprecated. Do you know what dip reflection is? Do you know what reflection is? More or less. Reflection is when you're calling, like, let's say, class by name or method by name or something like this. Dip reflection is when you need to set accessible true. That's the short story. Okay. So because if you, sorry.
Access private.
Exactly. So access private or package private, something like this. So if you're calling by reflection a public method or on public class, you're just doing a reflection, but it's not a dip reflection, it's shallow reflection. Dip reflection is when you need to set accessible to, for example, as Andrei said, get access to private members. So in my opinion, it got deprecated. Let's talk short about the modules, aka Jigsaw project. Modules are everywhere, or maybe not. Like for sure they are in JDK. I can show it to you. Java is has no more this rt.jar. So when you say Java list modules, see there's the list of the modules. So under the hood, JVM, or the whole JDK to be precise, is deprecated. It's divided into modules. But the thing is, the libraries and our applications are not so much into modules, and I very much like the quote from Kai Horstman from his book on Java 9 saying that modules are kind of social experiment. We don't know if they're going to catch, if they're going to become popular. Maybe they will, maybe they won't. For sure they're in JDK, but will they get smuggled into libraries and then our applications? We'll see. Why they introduced Jigsaw modules? Jar hell. Do you know jar hell, DLL hell, or dependency hell? Yeah. Okay. So a lot of people. Yeah. No. It's just modules are meant to address this jar hell. Now we have module hell, maybe, but maybe not. I think the module hell is, I think it's not as scary as jar hell. If you don't know what jar hell is, in shortly speaking, you could end up in a situation like your application was using dozens of jars as dependencies, and some smart admin just copied some of them because they were also used in another application and pasted them into Tomcat lib or JBoss lib directory to be reused. And then you upgraded your dependencies and they worked beautifully up to pre-prod, and in production they don't work because Tomcat/JBoss is still using the old ones because they happen to appear in the class path before your dependencies. That's why they're using all the versions of the API, and you get class not found or method not found exceptions. And I also think it's about better encapsulation. So every time we make something or we access something by dip reflection, we'll get warnings from JVM. Illegal access. And also my reading, it's about migrating from class path to module path. Because how to understand module path? I'm quite surprised nobody wrote that in their blog or book. At least I didn't find it. You guys know Git, right? Git is graphs, basically. So when you start thinking about modules or jars, once they turn into or are turned into modules as nodes in a graph, and that they depend one from each other, so we have actually not module path but module graph, things become easy. So think about, we had class path, and think about not module path but module graph. Okay, also for the subsequent slides. Then it's much easier to comprehend, I believe. So again, you can repeat after me, because many people say that we are not going to migrate to Java 9 or 11 or whatever because they are modules, and we don't want to rewrite our application to become modular. And they say that in Java 11 you need to have modules and module path. Shit. That's not true. You don't need to have modules. Well, sometimes you want to have them because you benefit from them. But it's like there's no heaven rule that you should be using or you must use modules in your Java 9 or later applications. So you don't need to rewrite your code, really. But remember that JDK is modular. There's no more LT.
It's one huge file which consisted of like 4,500 classes. So for desktop application, you also had to build the SQL classes or XML classes, right? Migration steps, how to migrate your application, if you're interested in that. First, I really recommend that you guys start using SDK Manager. It's really awesome to when you have to jiggle or swap your JVMs or JDKs. Then you should, quite of course, upgrade your IDE. Not exactly to professional.
Upgrade your IDE. Not exactly to professional version. What I mean is like to the most recent version of version using or recognizing such a Java language level. Then you should upgrade your build tools like Jenkins, Hudson, TeamCity, and Gradle and Maven and whatever you use, of course, because these tools, when they are like 5 years old, they will not work with Java 11, quite obviously. Upgrade containers if you have any, like Tomcat, JBoss and stuff. Upgrade all the dependencies. You should be doing that anyway, but usually there's this, if it's working, don't touch it, right? Don't touch it before it works. But sometimes, let's say if you happen to use Hibernate 4, using it in JVM 11 might not be a smart move to begin with. Okay, so maybe because of this, Sunmi is going to say if you'd like to start to first upgrade your dependencies, so the maintainers of the library or framework say, okay, it's working in Java 11 now or Java 9, you can proceed. You should try to compile still as target version 8 and just try to run it on maybe Java 9, 10, I guess 11 is your target version, or maybe 12. But still that bytecode is for Java 8 basically. You need to add explicit dependencies for Java SCE and other stuff that got decoupled, and this is important. I think that should test and automate like crazy in each step, because now Java is not going to live, given version for like 4 years or 5 years. The next version will be released after half a year. So what, are you going to repeat all the testing again manually? Maybe it's finally time to find some time and budget to automate this and really test it like crazy, because we've migrated, we shipped to production, or I did that to be precise, because everything compiled, everything worked smoothly, and after some time I had to roll stuff back, so I rolled it back, and I had to issue only 3 invoices manually. So I think it was still not that bad because of the only 3 invoices. Then I tested it to more extent, and we automated that, and now I think we are better covered, because this should be your general approach. If you find a bug, first you write a test that is red, and then you make the test pass, make it green, not skipped, of course. An extra migration step, maybe you'd like to compile to 11, using JDK 11, or compile from 11 and run it on 8. If you have not like this cloudish or SaaS services, but you, let's say, release your system like we do, and maybe you'd like to tune this illegal access to debug or deny, because you don't want to scare your users or customers with these messages. Who saw illegal access already, this warning? If you guys saw it, okay, we'll get to that. And to get rid of that, maybe you'd like to add this add exports, opens, and reads. Generally, 2 things may happen. first missing class or missing something, and illegal access. This one is fatal, this one is just annoying for now. So if you have missing applet or core bus, sorry, it's not going to work. If you have something from Javax, there's a very nice answer from Nikolai Padlock and also other people on, of course, on Stack Overflow, what to include as your dependencies in Gradle or Maven to make the thing build and work. If you have missing classes and methods, I guess you didn't upgrade your dependencies, meaning libraries and frameworks. That you still use something which is, for example, using these sunbiscan safe methods, which are no more. If any XX parameters are missing, I guess maybe you'd like to read the docs, this for the removed stuff, and see how to replace them. And you need to upgrade your scripts. And this illegal access. So now, because Java is modular, when you perform this illegal access, meaning, shortly speaking, this deep reflection, Java will write it to you, the standard output or standard error that you're performing on the code is performing illegal access. Yeah, because our applications might not be modular, the JDK is already modular, and yeah, so the default option for now is for illegal access is permit. I call it the friend option, because if you do something stupid, your friend will approach you and say, hey, I think you shouldn't be doing this, and the friend will just tell you at once. Okay, so just like illegal access permit, Java or JVM will complain only once, hey, in your application you're performing or you have illegal access. Then you have this illegal access warn. I call it the wipe option, which means every freaking time you perform illegal access, Java will complain, hey, illegal access, hey, illegal access, hey, do you know we have illegal access, and so on. Then you can have this illegal access debug. I call it mother-in-law option. It's like wife, only it will also tell you where exactly. See here you have illegal access here, and you have illegal access here, and also there. For it will print you a stack trace, pretty much like exception. And then you can have this, I call it father-in-law option, which means you can have illegal access. It will show you where, but only once. And after that, you're dead. You know, shovel, axe, and the stuff. You know, because you violated the daughter policy. So this is it. And the biggest thing about it is that they, whoever they are, warn us that one day this will be default. So maybe we'd like to get ready for this. And to tune that, to get rid of these options, there are these 5 needed options, which are add exports, opens, and reads, I believe, also add modules. We'll skip that in a moment. Just one more thing. Every jar we have in our class path de facto ends in one huge all unnamed module. Okay, so remember, thinking in terms of module graph, everything you like JDK or JVM under the hood itself will become modular or is modular, so it's part of the module graph. And if you don't use dash module dash path, just class path, everything is loaded into this module graph as well, only under or as one big all unnamed module. That's why you can still use these options, because here, like module using reflection, to open this package from this module for deep reflection, you can still use this all unnamed here. We'll skip that. This is our export, so it's just for public access. Add modules. It's like adding more jars to this module graph. So that, and also it's important for Java and 10, because these EE modules were present in Java 9 and 10, but they weren't enabled by default. So we had to enable them using this add module, basically. And add reads, you always forget that. Okay, so let's skip it. And patch module is like, because for modules to get us away from this jar hell, the rule is that a package can exist only in one module. Because what is a module? Module is just a jar file, but it's not in a class path, but in module path, basically. And you can also add their module -info class, or you can add automatic module name to be there. And if you happen to have like your monkey patching or something, and you have the same package in many jars, sometimes for various reasons, you need to say patch module to make JVM not complain about this. So you can say expressis verbis that this single module, that this single package can be kept in more than one jar file, basically. And if you have too many options, because for one library you can have 50 lines, for another you can have 50 arguments, and then you'll end up in a few screens of options, you can just use, I'll zoom it in, you can just use this javac option file 1 and option file 2. So you just group these options into files, and you use them for javac and for Java as this option file. One thing, they can't be nested. They are just flat, ordinary text files. When migrating, keep in mind that your mileage might vary. So I don't believe that there are exactly the same two migrations under the sun. Like your migrations might be different, and I'm pretty much sure they will be. Only the common steps I think are still valid, but you'll get some, like I know Nashorn folks got some other issues and so on. If you want to see trivial migration in action, there's this link to GitHub, to my GitHub. Because I wasn't able to show you the real application because of the NDA, you know, guys. But I kind of distilled the most important problems I saw into this simple trivial migration. It's available on GitHub, so you can clone it, fork it, whatever, and play it. And if you want to see, do you know Pet Shop from Spring, from Pivotal? Some of you know. So there's another blog entry from another guy how to migrate that application. Okay, so you know, as Linus Torvalds says, talk is cheap, show me the code. Let's see this simple migration just quickly. So this is the quite simple. First we're gonna have to check out branch or tag Java 8, and this is how we switch using SDK Javas. Basically, after installing SDK, I just call it SDK use Java in given version, and I have.
Sorry, could you make it a little bit bigger?
Still bigger? Okay. Okay. If you don't see something, just shout. Please don't throw things. Just shout. Okay. And then I'm going to call it to run it with Gradle wrapper. And what this application do? It does nothing serious, just like most of the applications we do. Okay. It's just we have some. Sorry, maybe I'll switch this presentation mode. So we have just ordinary POJOs or Java beans or whatever they're called persons. So we have Alice and Bob, which are children of John, and we print John, and then we create XML out of John using JAXB from Java EE. And then we print it, and then we encrypt it. You know, it's not encryption, yeah. Okay, but we show base 64 of John's first name, and then we take a deep look into John's first name as well, which means we are performing this deep reflection, as you can see here. So from string we get declared field, which is value. We set accessible, and we get the content of the actual character array of John, and we see what's inside. And if we run it, yeah, offline, okay, yeah, internet not reachable, see it should work. Yes, so I show it here again. So you know, this is git checkout, and this is saying basically that SDK use Java in this version. See, in this very shell, when I say Java version, I have Java 8 from Azure. In the other, when I say Java version, I have 11. Which is really awesome, because in two tabs, without setting these paths and, you know, these Java homes and other stuff, you can have many Javas running simultaneously on the very same machine, which is good when you like to migrate and compare the results. Okay, let's get to the output of this code. See, so we have this string, nothing fancy. We have this XML, nothing fancy, and we're going, yeah, the encrypted John looks like this. Of course, you know, it's not encrypted, and you can see the character array. So you know that Java string in Java 8 has inside character array. Now we can switch to Java 9 in this README. Of course, you might need to tune this Java versions. Why I'm using Java 9 and not jumping to Java 11 right away? Because of the JAX-B or generally speaking Java EE. Sometimes it's easier for you, let's say, to jump into Java 10, not to go to production with Java 10, but just to divide migration into little steps. Because I don't know if it works in Ukraine, but in Poland we have a joke, how to eat an elephant. And the answer is piece by piece. Okay, so here we are performing the migration again piece by piece. So I'm checking out Java 9 sources because we're not rewrite that, we don't have that much time, and running it. I'll show you the differences in IntelliJ. But see, now string has byte array. There's a byte 74, 111, and so on. So we don't have 8 bytes as John, we have 4 bytes in this array. Plus we also have this another byte for integer. So for John we don't have much saving. But anyway, let's take a look at this code. See, this character array became byte array. And what's also important to make that work, because let's see I don't add these options to compiler and I try to run it, not without checkout, just Gradle run. See, it failed because it doesn't know where to get from this JAVAX XML, or strictly speaking this JAVAX. So I'm using one of the options I have shown you, the add modules, and this in Java 9 and 10 basically says, hey, please enable this module for me. And also if I don't have these options, my friend is going to interfere. Why is it like this? I should see after running it, see this illegal access warning. And to enable warnings for the illegal or effective access operations, blah blah blah, i tak dalej. So we can say this illegal access debug. So we are switching to mother-in-law option.
Because of the space.
Space in the beginning. Okay, thanks. Who are you?
Thanks.
You're welcome.
Well, you have to double check it.
I'm not that bossy manager. Okay, can you see that? So see, I have told my JVM so to debug the illegal access, and now I see exactly where it happened. And because I have only one illegal access in my runtime, I see it just once. But should we have like a longer run, we'll see every time with a stack trace, so you know where it happens and you can address that. In this very case, well, ideally you get rid of deep reflection, because this is evil, this is bad, this is dragons, okay? But sometimes you need to do that because Spring. So then you can do that like this. You can tell expressis verbis add opens. We can use this add opens parameter / directive, and we can say that, hey Mr. open Java lang package from Java base module to everything that is in class path. Because this is what I'm doing. My application is accessing Java lang string internals. Okay, so open Java lang to the application, and that's why it's running. See, the jellies were one. Okay. Anyways, Java 11. So nothing changed here in the output, but let's investigate the build file or build definition. See, I had to add these implementations. This is like compile used to be. Now in Gradle you have implementation, or you shouldn't have compile, but implementation or API. And I can't add modules, use add modules, because they are no more in JVM 11. So I need explicit dependencies, and still the rest is valid. Okay, so see, that's why I divided it into 2 steps. So first I migrated into 10 or 9, and then into 11. I can also show you quickly other stuff. So what do we have here? Oh, Java Flight Recorder. So I have this application. It has 2 threads, consumer and producer. And as you can see, producer produces 3 megs, if I read that correctly, of data and sleeps 50 milliseconds. And consumer takes this data but sleeps 100 milliseconds. What will happen? What will happen? Sorry?
You won't go on.
Exactly. Sorry. Key will grow up, but let's say you don't have the code, you can't analyze it, you can't JProfile it or whatever. So we can use Java Flight Recorder, and we enable it like this. So we say XX start flight recording, write it to disk, dump on exit, which file, by the way, don't write recordings to TMP, and don't write logs to TMP. You know why, right? Okay, cool. It's just for a sample, and max sizes and path to GC routes. Anyway, once we run it, this file is created, and we can use it in Java Mission Control. I don't know how to zoom it, but this is Java Mission Control in action. It opened and analyzed this recording JFR file. And it can tell you various things just by analyzing it. Threads allocating. See, it says that there's this thread which allocates too much data, and it's app $producer run. So it will tell you which thread is generating this data. It can tell you that it was probably not enough free physical memory. That application holds that there were too many GCs when was the peak. And GC stores. GC, okay, we'd like to see the graph. It looks like this. Each GC is listed here. You can see in this chart how the memory grew, and so on and so on. TLAP allocations, if you will, memory issues. See what was generating it. And we have this. It's not like should have. Yeah. See, total allocation. We allocated the byte array. Yeah. Freaking good, I'd say. See, because I don't know if you have noticed, I have selected as run arguments what is your password, baby. You know, just to kind of make a link to the previous talk. And see, it found this password as Java argument, and to Java Mission Control, this looks suspiciously. It's so freaking good. It even analyzes the. Yeah, tell you, Mister, something smells here. Maybe you'd like to take a look, because you don't want to provide passwords as command line arguments. Okay, it's so good. It can show you exceptions. Here we don't have any socket.io, file.io, and so on and so on. If you are not into this fancy stuff, and you'd like to see it just logged to an ordinary file, you can use this unified logging. As you can see here, I'm logging in debug everything from garbage collector, and the file looks like this. Sorry, I'll make it a little smaller. Yeah. So you see the first GC and another GCs, and so the story goes. And this program runs for, I don't know, a minute and a half or 2. So eventually we have almost 200,000 lines. So you can really debug garbage collection in your application now, simply using this Java unified logging. Also, let me show you. Just will. Do you see this? Do you know what that is? The file is called make_var, but not war. .jshell, and I can run it in the jshell as kind of a feed or script. Yeah, jshell make_var. It's online as well if you'd like to analyze it later. So I'm using these new features, but you see, I'm feeding that. I could type it in JShell, or I could save it to a file and then run it in JShell. I don't need to Java C and then Java and so on. And the only odd thing is I'm calling exit at the end. So this is the directive of JShell. This is not Java code. Speaking of Java code, does it look familiar? Yeah, sorry, no more jellies, but you found it. It's the shebang. So it behaves pretty much like Bash script or Perl script or whatever script you ZSH is popular recently, right? So we have this shebang, and I'm using this Java from SDK man. I'm saying that this is source level 11, and see, I can then, when I list the files, see this file has executable flag set. So I can run it like this, JavaScript, and it runs. No calling JavaC, not calling Java. I mean, not directly. I mean, because it's in shebang. And here you can see that Java made a huge progress in supporting Unicode. Bloody hell. And also this is an indication that now the runtime gets better limits, reads the limits, let's say from like Docker in a much better way. Okay, I think this is it. If you'd like, because this talk is an extract from my 2-day training. If you'd like to have 2-day training or you have something to migrate, I mean, it's still direct flight from Wrocław to Lviv. Why not? Because there's much more to explore, guys. One huge for everyone, from every speaker at every meetup, conference and talk you visit, provide your feedback, because we speakers value your feedback, because it's good for us to improve our talks, our skills, and we can like understand what you'd like to have in the future. So you can even give that in there as a paper form, if you'd like, if you're shy of I don't know, filling some forms. This is it for tonight. This is the link to the slides if you'd like to have the slides and the code. And again, really, okay, you're taking pictures. And in the next slide, I have this really warm request to you to fill the poll, so I know what you think about this this talk. I guess this is it for tonight, at least when it comes to the official part. Andrei, now the raffle.
Questions to Piotr before we start the closing?
I mean, I'll be here and there if you have questions. Someone said something about some beer, or I don't know. So, no questions. Only
Java flight recorder, is it available in which Open JDK version?
Yeah, that's, sorry, I forgotten to mention that. To make releases of Open JDK easier, Oracle decided to open source it, because you could have seen Java Flight Recorder in action even for Java 8. It was just you had to use unlock proprietary or commercial features, something like this, and if you didn't pay for the license, theoretically they could sue you. Now it's open source for in Java Open JDK 11 for sure. It's open source, so we can use it. I mean, I'm not a lawyer, but as far as I can tell, in Java, in Open JDK 11, you can use Java Flight Recorder for free. I mean, free as in no money.